In the vast ocean of machine learning, a powerful technique surfaces known as Elastic Net Regression. It stands as a hybrid model, a combination of two popular methods, Ridge and Lasso Regression. But what exactly is Elastic Net Regression? Simply put, it's a regularized regression method that linearly combines the L1 and L2 penalties of the Lasso and Ridge methods. Now let's dive a bit deeper. In machine learning, numerous regression techniques exist, each with its own strengths and weaknesses. For instance, consider linear regression, a straightforward technique that models the relationship between a dependent and one or more independent variables. It works well with linear relationships but falters when dealing with nonlinear data or when the model is overfitting. Ridge regression, on the other hand, is a technique that overcomes overfitting by adding a slight bias to the model. It does this by introducing a penalty term, which discourages large coefficients. However, ridge regression has its own drawback. It includes all the features present in the model, even the ones that aren't significant. Lasso regression, another technique, overcomes this limitation. It not only prevents overfitting but also performs feature selection by assigning insignificant input features with a zero weight. Yet it can be overly aggressive, removing variables that might have been useful. This is where Elastic Net Regression shines. It blends the strengths of Ridge and Lasso regression, controlling the model's complexity and performing feature selection, all while avoiding the overly aggressive exclusion of input variables. Essentially, Elastic Net Regression holds the power of balance, maintaining harmony between bias and variance in the model. So, what are the key takeaways from today's dive into Elastic Net Regression? First, Elastic Net Regression is a powerful hybrid model, combining the strengths of both Ridge and Lasso regression. It controls the model's complexity, encourages feature selection, and avoids over-elimination of valuable variables. Second, it's crucial to remember that not all regression techniques fit every situation. Some techniques excel in certain scenarios and falter in others. Elastic Net Regression is not a silver bullet, but it does provide a compelling solution when dealing with a mix of different types of variables and when the model is prone to overfitting. Lastly, the world of machine learning is vast and ever-evolving. Techniques like Elastic Net Regression continue to push the boundaries of what's possible, helping to uncover patterns and relationships in increasingly complex data sets. In conclusion, as we navigate the ocean of machine learning, remember the power of balance and nuance that Elastic Net Regression offers. It's a testament to the progress and evolution of machine learning, a beacon of flexibility and adaptability in a sea of rigid algorithms. So keep exploring, keep learning, and keep pushing the boundaries of what's possible with machine learning.